Hi and welcome to a tutorial on standard form. Today we're going to be looking at just standard form with large numbers. So before we start looking at standard form, there's a few things that we need to sort of remember. The first thing would be the powers and indices of 10. So 10 cubed we know looks like 10 times 10 times 10, and as a value that's 1,000. In the same sort of way, 10 to the power 5 will be 10 multiplied by itself 5 times. And what you'll find is you'll get the 1 with 5 zeros after it. And as the pattern follows, 10 to the power 8 will have a 1 and 8. 1, 2, 3, 4, 5, 6, 7, 8 zeros after it. The second thing we need to remember is multiplying by the powers of 10. So things like by 1,000, 100, and 10,000. And we know that that has something to do with movement of place values. So if we say 42, if I write 42 there, which would make this units, tens, hundreds, thousands, 10,000s, 100,000s, and so on. We know that the decimal point will be there, and it's not the decimal point that moves, but it's the digits, and they move the amount of zeros that come after the 1. So if I can move these, so if I multiply 42 by 1,000, I'm moving the 4 and the 2. So 1, 2, 3. Ignore the fact that that decimal point just moved. It should have stayed exactly where it was. So the decimal point stays the same there. And it's the digits that have moved. The 2 has gone 1, 2, 3. The 4 has gone 1, 2, 3. And we now need to add the zeros in to make sure that the 4 and the 2 stays in the same place value. If we follow that same example with 4.5 times 100, I will need to remove my place value headings because they're not in the right place. We'll get rid of that 42,000 as well. And we start here with tenths. I'll just write it like that as a fraction, so it's tenths. Then we have our units or ones. Then we have our tens, our hundreds, and our thousands. And so the 4.5 will go 4 units, that decimal point, 5 tenths. And so when we move, what I'll do is I'll write in a different color so I don't have to erase the dot again. So the 4 will move 2 places because there's 2 zeros after the 1, and it goes 1, 2. So my new place will be 4 in the hundreds, and then the 5 comes from the tenths, and you get 1, 2, 5 tenths, and we need a 0 there to make sure that the 5 stays in the tenths place and the 4 stays in the hundreds. Decimal point remains the same, it never moves, and then you get the 0 at the end, which we actually don't need because 450 is the same as 450.0. Right. So if we were to do 0.85, we'd have to then remove the place values again, and we know that these numbers would have to move 1, 2, 3, 4 places to the left. Now, just to sort of make it a little bit more straightforward, we're bearing in mind that the decimal point does not move, but what a lot of people do, and some people may have seen in primary school, if we multiply 4.5 by 100, we sort of do this hoop movement. Really, it's the place value that's moving, but 1, 2, it still has the same effect, and you get 450. Right, so there's nothing specifically wrong with you doing it that way. You just need to bear in mind that it's actually the numbers that are changing place values, and it's not the decimal point that's moving, that stays constant. So 0.85 I could do as 1, 2, 3, 4, and it's 1, 2, 3, 4. That's it. Add the zeros to make sure that the values stay in the same place, and so you end up with 8,500 or 8,500. Okay, so moving on to standard form. Let's just get to the next slide. Right, so in order for us to, by the end of this video, I'm expecting that we should be able to answer what is standard form, why do we use it, write an example of standard form. We should be able to know the two conditions for a number written in standard form, and then use these three things to help us convert between large values to standard form and vice versa. Okay. Right. So why does standard form exist? Now, in science specifically, we've got quite large numbers, things like the distance from the Earth to the Sun, and that's 149 million kilometers, and a hydrogen atom has a diameter of about 0.0000002 millimeters. Okay, now these two values, one is a gigantic number, and the other is a very, very small distance. So when we're calculating and we're using big or small values, we might prefer, rather than having to, if I was doing some calculations, rather than having to keep writing 149 million like that, I may choose to write it in a much simpler way, which is 1.49 times 10 to the power 1, 2, 3, 4, 5, 6, 7, 8. Right, so some of us may be able to see what I've done there straight away. Others may not, and we'll look at what just happened there. We're not really going to cover this in this video, but this would then be 2 times 10 to the 1, 2, 3, 4, 5, 6 minus 6. Right, so standard form. In order for us to be able to write standard form, we need to know that standard form has to follow two very strict conditions. One, we need a number between 1 and 10, but not including 10. So 10 is excluded. Times a power of 10. So like we did before, 10 to the power 6, 10 to the power 5, or whatever. 10 to the negative, so 10 to the minus 3, 10 to the minus 4, or whatever. And that's when we're dealing with microscopic or small values, and that's when we're dealing with massive values or big values. Okay, so some examples. So if I want to convert 500 to standard form, bearing in mind I need a number between 1 and 10. So I'm going to write just there, a number between 1 and 10. That symbol for numbers is quite crooked, but yeah. Number between 1 and 10, and a power of 10 itself, times 10 to the power n. So that's any power. In this case, 500. That 500, if I was to place a decimal point there to make it a number between 1 and 10. I could make it 5 by adding decimal point there. So it becomes 5.0. We'll just keep the 0 just there. We don't need to, but nevertheless, 5.0. And then I need to ask myself, what am I multiplying by 5 to get my original figure? So that's going to be 5 times 100. Now, 100 written as a power of 10, and we saw before that the power of 10, the number that comes above there, is actually the number of zeros that follows the 1. So in this case, 5 times 100 is the same thing as 5 times 10 squared, which we know already. 10 times 10 is 100. 25,700. We can then change that to, if we need a number between 1 and 10, 2.57. And we're asking ourselves, what am I multiplying 2.57 by to get 25,700? So 2.57, and you should be able to see it right away, but if not, you're going to say that your 2 and your 5 and the 7 and the zeros, they need to move 4 spaces to the left. Now, if you're not sure on how many spaces they need to move, you can do that sort of hoop trick that I showed you earlier on, but you need to remember that it's the numbers that move and not the decimal point. This just helps us to see the motion a little bit clearer. So from the decimal point there, it's moved 1, 2, 3, 4. So the place values have moved, and so times 10 to the power 4. And that's that in standard form. That's done. Bit of a bigger number. So 4.923 is what we'll start with. And we're asking ourselves, what am I multiplying 4.923 by in order for me to get, I'll put my commas in so I can make sure I read the number, 49,230,000. So I'm going to do 4.923 times 10, because I know it's going to be a power of 10. And if my decimal point started there, and my digits are now going to move to make sure that it finishes there, it means I'm going to be moving 1, 2, 3, 4, 5, 6, 7 place values. So it then becomes 4.923 times 10 to the power 7. And that's pretty much it. That's how you change a large number into standard form. Standard form. Okay, let's just have a look at going the other way. So 2.8 times 10 squared. This, I think, is just a little bit simpler than this way, but that's only because we've just seen how to do going forward. 2.8 times 10 squared. 2.8, and that's the same as multiplying by 100. And we know when we multiply by 100, we're moving the numbers to place values. So that 2.8 is now going to go from your units, if that was my units there, it's going to go to my tens, and then to my hundreds. The 8 is going to follow and end up in my tens column. You can see it there. And then in my units, there's nothing, so I need to make sure 0 goes to make sure that my 8 stays in its tens and the 2 stays in the hundreds, and we get 280, and that's it. So at the end of it, 2.8 times 10 squared is 280. 3.97 times 10 to the power 6. So we got 3 0.97, and I want to make that into a big number, a whole number, multiplying by 10 to the power 6. Now I'm not going to show the movement of the place values because that's going to get sort of really messy with what I'm using to demonstrate this. So instead, I'm going to use the trick that I showed, but I will also stress that it's the numbers that move and not the decimal point. So 3.97, and then it's 1, 2, 3, 4, 5, 6, and we're putting our zeros in to make sure that the 3, 9, and 7 stay in the place value that they should be. And so that becomes 3, 9, 7, 0, 0, 0, 0. 3,970,000. Last one, 8.172 times 10 to the power 9. So we have 8.172. The numbers are going to move 9 place values. So I can use my hoops to show the 9 movements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimal point at the end. 0, 0, 0, 0, 0, 0. And so it's 8, 1, 7, 2, 1, 2, 3, 4, 5, 6 zeros. And that leaves us with 8,172,000,000. Okay, here are some questions for you to have a go at. 2 on each. Just have a go and we'll have a look at it when you get into school. All right, thanks.